Mercury, the first planet in our solar system. Mercury is the smallest and closest planet to the Sun, yet its characteristics are extraordinarily unique. While it shares similarities with our Moon in terms of surface features, Mercury's extreme conditions, fascinating geology, and complex orbital dynamics make it a subject of great scientific interest. Let's explore this small, mysterious world in even greater detail. Mercury's diameter is about 4,880 kilometers, 3,032 miles, which is slightly larger than the Moon, 3,474 kilometers in diameter. Its mass is approximately 5.5% of Earth's mass, making it a small planet by comparison. However, its high density indicates a large iron-rich core. Mercury's core is unusually large, making up about 75% of the planet's volume. The core itself is primarily composed of iron and nickel and is thought to be partially molten, which generates the planet's magnetic field. This composition is one of the key features that distinguish Mercury from the Earth-like rocky planets. The outer mantle and crust are much thinner than those of other terrestrial planets. Geological studies suggest that Mercury has undergone considerable tectonic activity, including shrinking, where the core's cooling has caused the surface to contract and form the large cliff-like features known as lobate scarps. The surface of Mercury is heavily cratered and displays many ancient impact-driven features similar to the Moon's surface. Notable craters include Caloris Basin, one of the largest impact basins in the solar system at about 1,550 kilometers, 960 miles, in diameter. The basin's formation released a shock wave that created a series of concentric rings, some of which are still visible. Some areas of Mercury's surface show evidence of ridges and cliffs formed by the shrinking of the planet's crust due to cooling and contraction over time. Hollows. These are mysterious features found mainly in the planet's northern hemisphere. They are depressions that appear to be caused by the evaporation of volatile materials, possibly sulfur or carbonates, hinting at active geological processes even in Mercury's ancient past. Mercury's orbital period is 88 Earth days, making it the fastest orbiting planet in the solar system. The planet's orbit is highly elliptical, with a semi-major axis of about 57.9 million kilometers, 35.98 million miles. This elliptical orbit causes significant variations in Mercury's distance from the Sun. At perihelion, closest to the Sun, Mercury is about 46 million kilometers, 28.58 million miles away, while at aphelion, farthest from the Sun, it reaches about 70 million kilometers, 43.5 million miles. Because of Mercury's elliptical orbit and the way it rotates, the planet experiences resonance between its rotation and orbit, which creates a unique day-night cycle. Mercury has an unusual rotation period of 59 Earth days. However, due to its eccentric orbit, a solar day on Mercury, the time it takes for the Sun to return to the same position in the sky, lasts about 176 Earth days. This means that a single day on Mercury, sunrise to sunset, lasts more than twice as long as its year, leading to a very long period of daylight or darkness, depending on the planet's position relative to the Sun. Mercury experiences a spin-orbit resonance, which means that its rotation period, 59 days, is in a 3.2 ratio with its orbital period, 88 days. As a result, Mercury rotates 3 times for every 2 orbits it makes around the Sun. This is why one side of the planet is always facing the Sun for long periods, and the other side remains in permanent darkness. Mercury doesn't have a true atmosphere, but instead, It has an extremely thin exosphere composed of trace amounts of gases like oxygen, sodium, hydrogen, helium, and potassium. This exosphere is constantly being replenished by solar wind, micrometeorite impacts, and volcanic outgassing from Mercury's surface. The lack of an atmosphere means that there is no weather, no clouds, and no breathable air, leading to temperature extremes across the planet's surface. Due to its lack of atmosphere, the planet experiences extreme temperature fluctuations. On the day side, temperatures can soar up to 430 degrees Celsius, 800 degrees Fahrenheit, while the night side can drop to 180 degrees Celsius, 290 degrees Fahrenheit. These swings occur because there is no atmosphere to trap heat and distribute it evenly. The extreme temperatures, coupled with the absence of liquid water, make Mercury a hostile environment for life as we know it. Mercury's magnetic field is about 1% the strength of Earth's. Despite its small size, the planet has a significant magnetic field generated by its molten core. Scientists have suggested that this may be the result of a partially liquid outer core and a solid inner core, creating a dynamo effect. Interestingly, Mercury's magnetic field is highly asymmetric, with the northern hemisphere's field being significantly stronger than that of the southern hemisphere. Unlike Earth's magnetosphere, which provides substantial protection from solar radiation, Mercury's magnetosphere is much weaker. As a result, it is more susceptible to solar wind, the continuous stream of charged particles emitted by the Sun. However, Mercury's magnetosphere still plays a role in deflecting some of the solar wind, particularly in the planet's polar regions, where the magnetic field lines converge. The discovery of water ice in permanently shadowed craters near Mercury's poles has been a major revelation. NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, detected polar ice deposits that are protected from the Sun's intense heat. This ice is believed to be more than 2 billion years old and may contain clues about the early solar system and the possibility of volatile rich materials on the planet. Mercury's surface shows signs of past volcanic activity, particularly in the form of smooth plains that suggest ancient lava flows. These volcanic deposits likely occurred billions of years ago when the planet was more geologically active. Mercury is one of the oldest observed celestial objects, known since antiquity by civilizations like the Sumerians and Babylonians. In ancient times, it was often confused with the star Lucifer or Hermes, the Greek god of messengers and travelers, due to its fast-moving orbit and brief periods of visibility. Because of its small size and location, Mercury's proximity to the Sun means it has one of the highest orbital speeds of any planet, traveling at an average speed of about 47.87 kilometers per second, or 107,000 miles per hour. Mercury is named after Mercury, the Roman god of communication and travelers. Its quick movements across the sky were noted by ancient astronomers, who linked it with the swift-moving messenger of the gods. Mercury remains one of the most fascinating planets in the solar system, with its extreme temperatures, unusual orbit, high-density core, and mysterious surface features. As space exploration continues to advance, new missions such as the Bepi-Colombo spacecraft, which launched in 2018, are expected to provide even more insight into this enigmatic world, helping scientists to further uncover the history and dynamics of our solar system's smallest planet. From its volcanic past to its current state as a frozen world with potential water ice, Mercury's story is one of change, mystery, and discovery.